Hi, geometry. We are in Unit 1 still. Lesson 19, we're going to talk about evidence, angles, and proof. So let's start out with supplementary angles. That might be a word that kind of rings a bell, but you're not really sure because it's been a while. Supplementary, that means that you have two angles that their measurements add to 180 degrees. Okay, they're supplementary. So any two angles, what their measurements are, and they add to 180 degrees. So if we mentally evaluate all the missing angle measures in each figure, that means we're not supposed to use a calculator, which can be challenging sometimes. So if I have 50 degrees, this one would be 130 degrees. Okay, because you add those together and you get 180. If this is 30, this a straight line is 180 also. You should probably remember that. A straight line. So this would be 150. And if this is 150, I have a straight line right here. So that would be 30. And I have a straight line right here. So this would be 150. Cool. I could also say that this angle right here is 180 degrees because it's a straight line. 65, let's see, 65, 70, so this would be 80, 15, 115 degrees. Yeah, that's right. Which means on this side we have 180 degrees. Okay, if I have 135, I assume you see where I'm showing you a straight line. I can't draw a straight line very well. That's a straight line. Straight lines are always 180 degrees. So if this one's the 135, we have 140 plus 40 is 180. So that would be 45 degrees. All right. Here's another straight line. So that means this is 135. That first straight line again, so this is 45. Cool. All right. Moving on. Okay. So now we're going to talk about, we're going to lead this into an actual lesson. So where it says right there, images for launch, I want to talk about what we see there. So we're just going to talk about these. What do you notice? What do you wonder? Okay. I see solid lines and dashed lines. Easy one. I do see a horizontal line like this one in all three. So that's a line, and we know a line is 180 degrees. The two solid angles, like this one and that one, they make what's called a linear pair. It's a very important, very important vocabulary word in geometry. A linear pair, two angles that form a line. They're also supplementary. So we see that these two angles form a linear pair or a line. When you erase those angle marks, though, they'll get confusing. In fact, all of the solid line angles, like this one right here and that one right there, let's just leave it there. So this angle, I'm going to mark it from there to there, and this angle are a linear pair. This little guy and the bigger side, linear pair, because they form a straight line, linear pair. So those are all supplementary. I wonder about the bisectors. Really not sure what they are. Let's get a different color in here. The dashed lines, are they bisectors? That's a question mark. Are the dashed line bisectors? Looks like they could be. Bisector means that that side and that side are equal, and that little one and that little one are equal. Are they bisectors? I'm not sure. It looks like they can be, but we never, ever say that something is true because it looks like it. Okay, that's a big, big, big geometry no-no. Do the dashed lines make a right angle? Here's the really important part. I'm going to put it in red. This dashed line, we're wondering, is that an angle bisector, first of all? And then when they form together, is it a right angle? Okay, so interesting. Geometry is just fascinating, I believe. So all of these, we wonder if they make a right angle, right? All right, so now we're getting into the lesson. All right, so here I have a figure where ray R meets line L. And what's really crazy is whenever I've drawn a ray has an endpoint and an arrow at the other end, and a line has arrows on both ends. That's just what I know about a line and a ray. Now the dashed rays, which are these, are in fact angle bisectors. That means that it splits, this angle is split into two, so I can say this angle is equal to that angle. Okay, we're going to get all those lines out of there because that'll be so confusing. So the angle bisector, it does split the big angle or the small angle in equal pieces. What do we need to know about this? So Diego made the conjecture, and remember, conjecture is just a guess. The angle formed between the angle bisectors is always the right angle, no matter what the angle between R and L is. It is difficult to tell specifically which angles Diego is talking about in his conjecture. Label the diagram and rephrase Diego's conjecture more precisely using your labels. So let's label this in things that make sense. I'm gonna just change colors here. I just need to be able to, if I'm talking about an angle, I need 3 letters. So we're gonna label that C, and I'm gonna come over here and label B. Now let's come up here, D. Over here, I'm gonna label that E, and over here, label that F. Cool. All right, I'm still working on number 1 though. Now, let's see, it says, difficult to tell which angles, label the diagram, and rephrase Diego's conjecture more precisely using your labels. I'm going to say, in very mathy words, given that ray CE, which I could also just do CE with a ray over it, those are equal, bisects angle ACD. Hold on, someone's walking into my classroom. Sorry about that. Someone was in my classroom. Where was I? Bisects angle ACD into 2 congruent angles. Oops. And instead of the word congruent, you can always use the symbol. We'll put it up there. It's like an equal sign with a squiggly above it. Instead of using the word angle, you can go like that. All right, that measure. Oops, that's not the word measure. That measure, we can call it A degrees, which means I can come up here. Let's see, I did CE, so I will draw this and go A degrees, and this and go A degrees, and that ray CF bisects angle BCD into 2 congruent, using all the shortcuts now, angles that measure, and we'll call it B degrees. I'll come over here and label this. That's 2 tick marks. And that's a measurement, so I put a degree sign in there. Okay, not done, almost. Then angle ECF is a right angle. Okay, and I could even use the symbol here, angle. In other words, I can say that A plus B equals 90. Okay, which is really cool. Lots of words, right? Now, is this conjecture true? Explain your reasoning. Yes, it actually is true. I think I might be out of paper though, out of space. Is this conjecture true? It is. Because angle, let's see, let's change colors. I'll start writing here. Because angle ACB forms a line, ACB, I need to see it. ACB forms a line because it is a line. That's how I labeled it. And that measures 180 degrees. If I bisect, well, that forms 80 degrees. If I do 2 times A plus 2 times B, that's going to be 180 degrees, right? So now I can do some algebra magic, factor out a 2, divide both sides by 2, and I get A plus B equals 90. Okay, I think that can be magic, right? That's pretty cool. So yeah, those all make sense. Mathematically, algebraically, geometrically, all make sense. It's pretty cool. All right, really important here. Convince me. So here we're talking about 2 intersecting lines, and we create 2 pairs of vertical angles. This is another vocabulary word that's going to be super duper important because we're going to use it quite a bit. So I've got 2 pairs of, so what is the relationship between the vertical angles? Write down a conjecture. We're just going to go through it, where here I have a line, and we're going to label this angle A, angle B. No, let's do this. Angle A, angle B. I said angle B and wrote angle A again. Cool. Angle C and angle D. All right. So I know that A plus B equals 180. I also know that D plus C equals 180. Okay. In algebra, we learned when 2 things are equal to each other, like this is 180 and that's 180, therefore I can say that A plus B equals C plus D. All right, because they're both equal to 180, they're both equal to each other. Now I can say that, hold on. I'm going to do something real quick. That's actually not the way I'm going to go. That is a little higher level. It's going to be hard to explain. We're going to do that, just not today. All right, let's talk about reflection. Let's do it that way. Okay, that's going to make much better sense. If I angle bisect this and this and reflect over, I can actually get A onto C. We're going to call it angle A onto C. Okay, now let me erase that. And then I can also reflect angle D onto angle B, okay? Another way I can look at it is a rotation. If I rotate, and we'll call it center X, I can rotate angle A onto angle C. a rotation of 180 degrees. And the same with B and D. I did that backwards, but it's okay. With a rotation of 180 degrees. So rotation works also. What we know is AX, let's not use A. X, Y, Z, W, Q. Angle YXQ is congruent to angle WXZ because they are vertical. That's what they're called. I can also say that angle WXY is congruent to angle ZXQ because they are vertical. I always thought of it as they are across from each other. Okay? They're also formed by linear pairs. When two lines cross, they form two vertical angles across from each other. All right? That's really it. Is there anything that I need to tell you looking ahead? Nope. Let's do our summary. That's all right. The summary's not in here. Oh my. There's none in my written book either. All right, I'll make sure that we have that in the next lesson to make sure you get those vocabulary words, okay? Good job today.